Well, hi everyone, and we're just about to start another radio, a really interesting one here. Something I've never worked on. This is called a farm radio. I'm lucky enough I already have the schematic and some information on it. It's a General Electric excuse me, model C57B. And what sets this guy apart from many other similar looking radios is that this one has no power supply in it. It has to be run from batteries, and of course that's pretty tough to do these days. So that's what it looks like on the front. Seems to be in pretty good shape actually. There's some damage to the speaker here, but pretty minor stuff. Yeah, appears to be a... what would this be? Well, that's interesting. Maybe that's the on-off switch going there. What is that? Take a look at how this works. Already, never seen anything quite like that. Can you see the string comes down, it goes around this arm, and this color changes here. So I think that's on, and that's off, and that's got to be the most unusual on-off arrangement I've seen on a radio before. It has its tubes, but I'll bet you this thing has not been operated, you know, since I'm going to take a guess, 1955. The last time this thing ever operated. You had to go out and buy batteries for it. You had to buy a 90-volt battery to run this radio, and then when the battery was spent, you had to go buy another one. And I think they were called farm radios because the idea was you could take them out to the barn, which had no electricity, and play your radio out there. Just going to neaten this up a little bit. This wire extension can come off. Looks like antenna and ground wire here. And these, let's see, long wire. So I get the impression this must have been in a large cabinet. These wires are really stiff though. They cannot be bent, so they're permanently in this shape now. That's not so handy, is it? They're going nowhere. And I have to replace all this. So my intention with this radio is, like any radio, to get it working, and I have temporary power supplies. I can supply the necessary 90 volts, and obviously there's some filament voltage that needs to be supplied. Maybe it's stated on here. And well, I don't see it offhand. In a quick hunt here, I don't see the actual voltage written on the plan. Yellow, blue, black, and I'm not sure what that says. How do you like that? The tubes are 1A7, 1NS, 1NS, 1C5. These are all quite unusual tubes. 1NS. I don't think the 1 means 1 volt, but I might be mistaken about that. I'll have to do a little research here. But I have to supply a voltage for the heaters of some sort, and the 90 volts, and then some of these wires have to be for the speaker. At least I imagine they are. These are all coming out bundled together. 4 wires. Now, what's going on here? Why would it be like this? It's just 2 wires two wires going to two plugs with three contacts. Now what the heck is going on here? So 3 contacts are forcing polarity into this plug. Only 2 of them are used, so I think, pretty sure these are going to be the battery plugs. And I'm guessing you get 2 45-volt batteries and you put them in series, because there's one wire through here just loops to the other one. So I'm thinking you buy 2 45-volt batteries, you plug them in, you get your 90-volt B+ that way. And that would leave this one as either the speaker or the heater. Now wait a minute, it can't be the speaker. The speaker's built in, so this is not the speaker. So this is the heater wire. There is no external speaker. So that's very odd, because you'd think this long wire is to enable this radio to be in a big cabinet. That doesn't make a lot of sense either, because you think a battery operated radio would be a pretty small affair, you know, kind of portable, to make use of the portability. So I'm not getting it. If it were in a big cabinet, then it would almost certainly have the big speaker in the lower part of the cabinet. It wouldn't have this little one mounted in here, and not really the case, unless somehow the battery sat quite remote from the radio, which I don't know, don't understand. So maybe I'll find a picture of you know, something more than just the schematic. Maybe I can find a photograph. But I'm pretty sure this fits in a little box, big enough to hold the battery. Why all the wires? I don't know. Okay, so enough on that. I think we got that sorted out. I can't even move them out of the way here. I'm gonna cheapers. You know, I tried to maintain everything as original as possible and replace as little as possible in these radios. So I'm not anxious to start cutting away these wires, even though they're in such poor shape. So let's have a look at the tubes. They're all there. Take a little closer look here. Yeah, it doesn't look like the radio's taken any abuse. Tuning capacitor, this all works nicely. It feels nice and smooth. So we got to really determine, you know, I can't do much more until I determine the heater voltage and positive and negative on this. I mean, these are polarized, but they don't say which way on them anyway. So if I had a battery, I guess I could kind of look at the battery and figure out what's plus and minus, but I don't have one of these batteries. So I might have to follow these wires underneath the chassis and sort it out from there. And speaking about that, let's take a look under the chassis here. What we got? Excuse me. Still got remnants of my cold going here. There we go. Yeah, I think these wires are going to drive me nuts. Okay, nice and clean inside. Not a bad actor. This guy looking a little new. It's actually looking in pretty good shape. You know, when you hear farm radio, you kind of imagine it's been out with the chickens for 20 years, but it doesn't look like it. Lots of paper caps in there. But as older capacitors go, these look to be in pretty good shape. Look at this one, looks really good. There's really no evidence of high humidity, but it is an old radio. So you know what, this might work. That we can just get a little voltage going now. What is this? This is a multi-band radio. The switch is all connected to these capacitors, so I don't think it's a tone switch. I think this is the tone here. Wait a minute, there's a switch back here. So what's this funny string thing doing here? Just moving the mechanical indicator. That's all it's doing. So the string moves the mechanical indicator. The actual switch is on the back here. It appears to be switching two things. It's probably switching both the high voltage battery, the 90 volts, and probably the low voltage too. Oh, here's another switch here. This looks like a tone switch to me. This looks like a tone switch. So probably this is on, off, and volume in combination. So I think we figured that out pretty easily. Still curious about this band. You know, it has a large front on it, so there's room for more than one band. And let's just put a wrench on it here. Really give this switch a good turn. It's a two-position switch. There's no more in it. So it could be AM and shortwave. I have one shortwave band, but a little hard to tell with what I've got here now. Maybe it says something. The alignment would probably give it away. Yeah, there we are. There's alignment instructions at 9.6 megacycles. So it's got it's got an AM band and one shortwave band. Okay. There's the little tuning capacitors. Oscillator, 9.6 megacycle oscillator, 60. It's a 9.6 RF. Excuse me, please. The IF frequency is 460. And it looks like your basic radio here. So next step is sort out what the voltage or current should be in the filaments of these tubes, and figure out the polarity of the B+ lines so I can hook them up. And we'll see what happens with this guy. So I'm off to do a little studying on the tubes. Okay, so I did a little studying on the tubes here. There's 3 1N5s, 1 1A7, and 1 1C5. What they have in common in terms of their filaments is they all run on 1.4 volts. 1.4 volts is a very suspicious number because I'm pretty sure it's the output of a battery like this, an ordinary battery. Even though they say 1.5, I think they actually put out 1.4. So I'm pretty sure that's what that is. It's just basically take your basic dry cell battery, and that powers the filaments. They're all connected in parallel. Most of them take very small current, 50 milliamps at 1.4 volts. And of course this battery I'm testing is, well, okay, it's an older battery. It's reading 1.466. I think, you know, when you measure these, they actually get 1.6. But in any case, that sure sounds like an ordinary run-of-the-mill, what we might call a flashlight battery, powering the filaments. But all the tubes take 50 milliamps. One takes 100 milliamps. That's the output tube. So that'd be a total of 300 milliamps draw on the battery. That sounds like a pretty heavy draw to me. It sounds like it would drain a regular D cell pretty quick. But of course the batteries that were intended for this radio, they could have been much larger in terms of their capacity. So now my question is, where am I going to get 1.4 volts from? Now a pretty safe place is a battery like that. That's a pretty safe place to get it. I also have a supply here, but this supply is a little wonky when you get it down low. You can see my voltmeter jumping up and down there. You know, it settles out at around 2 volts. I'm a little anxious about hooking it up to a power supply that could suddenly deliver a much higher voltage. On account of, I don't think these tubes will take much abuse. Let's see what this actually says. Okay, so this is turned right. Oh, see that? I don't know if you can see that. That meter just jumped right up to 15 volts. Let's see. Yeah, there's 15 volts on the output. Look at that. So I can't use this power supply because of its erratic nature. It might be dirt in this knob. Doesn't matter what it is, I can't afford to have that happen. If that happens while this thing's supplying the filaments, that'll be the end of those tubes. I don't want that to happen. So, you know what I'm going to do? I'm going to use a battery. Here's another one. Let's just check that one. So this one's 1.5 volts. So if I take a little bit of a weaker battery here, it's just about dead on, 1.4. Probably put a little load on it, it'll probably drop well below 1.4. I think we're safe to use this. Wait a minute. Now, this I think is the battery lead here. Let's see if one side is connected to ground. I think it will be the case. It is grounded, I'm just making bad contact here. Yeah, right to 0. And the other side, I suppose I'll read some filament resistances here. And this shows open. I'm only assuming this is the feed. It's a good assumption. I'm assuming this is the feed to the filaments. It's really a very good assumption. This is reading open circuit. How about trying that now? I'd read somewhere that these low voltage tubes can be damaged by an ohm meter. Okay, so that's now reading essentially 0, and the other side is the 0. Okay, so we have continuity when the on switch is on. Pretty sure that's the heater. So I'm really worried about the heater, getting that right, because if I make a mistake there, I will damage these tubes. If I make a mistake on the B+, unless I do something really crazy and put 500 volts on it, I don't think we're going to hurt the tubes. 90, 100, 80, it's not going to make any difference to the tube. So I'd have to verify this a little bit, and then we can supply this, and then these guys. Now, I suppose one of these may go to ground. Let's see. That may help us identify which one's the positive lead. Either this one or that one. No sign of a ground there. Maybe it's on this one here. Phooey. Didn't see anything happen there. Got my meter right? I would have thought one of these would be grounded on the chassis too. So let's trace these wires a little bit. This is the brown and yellow. The brown and yellow actually comes in to the radio. Is it here? Where is it? It's coming in. Here they are here. This schmozzle here. Going through the switch. So, I would imagine one of these is grounded. That one back there. And probably this one back here. Yeah, so those are the ground connections at the back there. Let me just turn the set off and see that those keep going. No. We open the ground. Oh, that one's still grounded. So how's this switch working? Is it these two? These two that connect? Okay, so when the switch is thrown, this connects to here, and the one in the back connects to there. The switch is open. We get ground there, and no ground there. Perfect, okay. So the ground is applied to the red wire. Red wire is going to the heaters. So the back switch is switching the heaters. The front switch, which has this black wire, so the black wire is the switched wire. It doesn't mean it's the positive one. The black wire, this blackish wire. The blackish wire. Is that for sure correct? Let's see. The black wire comes to here. And it goes to here. So there you are, Mr. Black Wire. From there, it heads down to this tube. That's probably the output tube right there. Probably. The other wire is heading to here. What is going on there? Lots of parts hooked up there. There's no pin in the tube at this location, so that's a connection point. It's not a ground point. Let's see if we can trace these on the circuit diagram here. The blue, well, the one I'm calling black is probably blue. And yellow. Yellow looks yellow. So the yellow connected to a resistor to the output tube. Grid. It says B minus. The B plus going through a switch, connecting through the transformer to the plate and elsewhere to screens. Probably to these other plates, yep, via the screen wire. So the black one is the positive one, and the yellow one is the negative one. The yellow one's not directly grounded. It's isolated from ground by its resistor. So that explains the readings. So we can stick 90 volts. I'm sure we can try 90 volts on here. And gee, what I was reading here is RF something. I bet you that's red. R-E-D, red. So it's a red wire and the black wire. So it all confirms what I've come to conclude anyway. So I think we should hook this guy up and get him going. I mean, what's the worst that can happen? So our first challenge is how do you hook up a battery to this plug here. Where'd it go? Here it is. I've got a little battery holder. I don't think I have a little battery holder. I could solder wires. That's kind of a hassle. Hey, no, I don't think I have a little battery case. I got battery holders for other sizes, but not for this size. Oh, well, I could always use a different size. I can use one of these. Why not? Just gotta find my battery holder. So I'll tell you what, I'm gonna set this up. I'll stop the video and then I'll start it up again when we're ready to actually try the radio out. Okay, well, I'm actually gonna solder some wires onto this battery. I think that's my best approach, all things considered. It's been a long time since I've soldered wires to a battery, that's for sure. Okay, I'll use the red marked lead here as the positive. Try to, I guess it doesn't matter that much, really. It doesn't matter the polarity of the supply to the heaters. I imagine it doesn't matter very much. There we go. As soon as I connect these wires, no, that's not right. Make sure the set is off, and I think I'm just going to use clip leads for here. So put the red one on the red one. I like to bend them like this so there's much less chance of a short occurring. There we go. That's about ready, and these leads are going to have the 90 volts on them coming from my supply here, which is switched off right now so we can get everything ready. What had I figured out before? I'd figured out that yellow was negative. So we're going to clip right inside the radio here. I think is probably a better choice than using the wires. So that's on the yellow. That's good. And then this one goes, this is the positive, and that goes on the black or blue wire, which we determined was this one right here. And the set is turned off. I don't have a meter to read the current flow. Should I bother with that? Current flow into the heaters? You know, I don't think I need to bother with that. This thing can only put out 1.5 volts, no more, no matter what. The worst case, this battery can't deliver the current and the heaters don't heat up as much as they should. That's the worst case. I can't see that there's any risk here with that. On the B plus side, without the heaters going, I will apply B plus. We'll discover if I done this right. Is there a shorted capacitor or any other problems in the high voltage circuitry? So set is turned off. This battery is connected to nothing, so we'll turn on our supply. Make sure that's down. It has a vacuum tube in it, so I have to give it a moment to warm up. the volts on this side, the current flow on this side, the red line at 100 milliamps maximum output current. It's still on standby right now, so there should be no voltage being supplied. Okay, so all the action is going to be on the up here, volume, yeah. Voltage down, switch on. The voltage popped up just a little bit because 0 is never 0. Now we got to watch this meter as I turn it up towards 90. 90 is just about there. So here we go. Up, 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 up to. Okay, so we're at the 90 point. This is 0 current flow. Okay, so take it down. Now we'll turn the set on. There's no current flowing to the heaters. We will now turn this up and watch again and see what the current does. I would expect it to go up a little bit. Up, 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 up. Okay, we're about almost 100 volts. 0 current. Okay, so we'll turn that back down. The voltage has gone down. So we're set to go here. We're set to make this radio do something. Switch the radio off. Connect the heater lines up. Positive on red. Positive on red. So when we turn this on, we should start drawing some heater current. And I don't know if we can see any of the elements heating up on this. Let's check it out. Take my super sensitive camera over here. And turn off a few lights. It's quite dark in here now, even though the camera is seeing fairly well. And we're going to kind of look down into this tube here. The camera's working funny under low light, isn't it? So I'm going to switch on the set now. It's on. Well, I don't see anything that suggests heat in that tube. What about the other ones? The camera's not focusing now. There's not enough light to operate the focus on it. Okay, let me look with my own eyes and see. Well, I don't see anything, but that doesn't mean they're not heating. Let's do this. We'll measure the voltage across that battery and see if there's anything left, in case the battery's gotten all oomph. 1.35. So, okay, it's down a little bit. Switch is on. Let's bring on a little voltage now. Okay, so we'll turn this guy up to. Okay, so we're kicking around 90. Still no current draw at all. And what can we hear? Oh. I don't hear a darn thing. Okay, a few checks here. Do we really have 90 volts at the end of these leads? Might not have 90 volts there. Why would that be? Well, what's going on? Let's just check to make sure there's really 90 on the output here. Right back at the supply. Yeah, made a little mistake. Wrong ground. Okay, quick test. Here we go. Slight current draw now. I've got this on the right wire. Very good. Looking good. Looking good. Sounds like nothing. Okay, well that's good for a first test. Even though it didn't work.